Hello friends, this is Ranit. Today I'll be doing the fourth experiment of the System Software and Compiler Lab, which is token separation using Lex tool. So as we did token separation in the first experiment, but that was not using the Lex. So Lex is an inbuilt tool which we get in Unix file systems, and it is done to identify different types of input. So to perform token separation using Lex program, we have to match for a defined operator punctuation, digit, alphabet, and the above. So this is the algorithm where we declare the count value 0 in the declaration selection, initialize the operator punctuation, digit, alphabet, and keyword in the definition section of the Lex program, match the given input to the above set of definitions, increment the count for every matching symbol, print all the symbols which matches the symbol without their type. In the main part, we call the function YYIndex, which is predefined in a Unix system in order to start the program, and we end the program using YYWrap. So this is the program which we have over here. Initially, we define count is equal to 0, and these are the declarations that we are making. So if the system encounters the following, then it is an operator. Now this is the OR symbol, so if the system encounters any of these symbols, then it is a punctuation. Then from 0 to 9 it's a digit. Then from small a to small z and capital A to capital Z, it is an alphabet. And we define a keyword as int or float or double or boolean. These are the keywords. Next comes the declaration part. So here we increment the count and we print the if this is there, then we print punctuation, then we count. Since if there are more than one inputs for the given punctuation, then the count needs to be increased, right? So that's why we do count plus plus operation over here. And at last we add YY text in order to include it in that. So if it's an operator, then once an operator is encountered, this line gets executed and the count for this gets incremented. Similarly, if it encounters a punctuation, then this line gets executed. If it encounters a keyword, then this line is executed. If it encounters a digit, then this line is executed. Now since there may be many combination of digits, so that's why we have digit star. And at last, if it's a alpha followed by alpha and digit star, then it is an identifier. So I'll explain this once again. Now in a number there can be many digits, so that's why we use digit star over here, because digit is for 1 and digit stars means as many as digits can be there, and it's possible that there can be no number, so that's why we have a star over here. And now we know that identifier must start with a alphabet and can end with either digit or alphabet, or it can just be a single alphabet. That's why we have a star over here. And at last we have the main function where we'll just